collaborators, Andhra Pradesh State Council. So let me share my slide. I hope my whole screen is got shared.
Yes, sir, visible.
Fine. So I welcome you all. Once again, I welcome you all in this wonderful afternoon session, Faculty Development Program on Quantum Technology. We are running QT02, Foundation of Quantum Technology. Under this series, today's given topic is IBM Quantum Qiskit installation and programming. So let me introduce myself. I am Jayakumar Vaidishankar, acting as Chief Executive Officer, Anatandra Private Limited. We are based in Bangalore. So today we're going to see about this one of the framework developed by IBM Quantum and why we are using it. What is the advantages this tool contains and how to proceed both graphical oriented as well as programming oriented. So we can see both ways. So for each and every one of you, starting with GUI based is very easy because I hope most of you coming from different backgrounds, not only from computer science and IT, from physics, chemistry, maths, EC, triple E. So it will be easy for you to go with graphical based. So it is like playing games. Okay. So with that note, I try to shift my windows to this website. I'll share this link with you. How to put chat box. Yes. So check your chat box. I shared one link. Are you able to access? IBM.com quantum/Qiskit. So go and click this link. You will end up with this web page. Good. Okay. So this is a very beautiful website. You can use most of this framework. So maybe I'll take notes side by side. Okay. So let me write what is the meaning of Qiskit. So Qiskit stands for quantum information science toolkit. So this is the expansion of Qiskit. Okay. So this is developed by IBM. This is developed by IBM. Okay. So the entire Qiskit is a framework. It is a SDK, software development kit framework. Okay. So what is the meaning of framework? You can design, you can develop, you can test, you can implement all your coding, everything in a single platform. Okay. If you're able to design a circuit, if you're able to develop a circuit by using programming, if you're able to run, if you're able to execute, everything happened in the same platform, then you can call it as a framework. Okay. So SDK means software development kit framework. So let's see how this QuizKit is designed. So it is designed based upon the graphical user-based interface, graphical user interface. So whatever you can do, you can drag and drop, you can write coding, you can do in multiple ways, right? So go to this website, and this is how you need to install QuizKit in your Jupyter Notebook or Google Colab. So we'll start with this basic stuff. Okay, so you can see all the statistics. So if you are using any tool, if you are doing any research, there will be a fundamental question whether the tool is reliable and how many users are using and how familiar it is among the scientific community. So based upon this data, you can say 13 million downloads happen for QuizKit software. Okay, so nearly 13 million times the software is downloaded. It has the strong user base. Okay, then you can see for all developers who are using quantum framework. So among 74% of developers prefer Qiskit. So this is the majority of quantum developer which they prefer to use. Even Google is there, Microsoft is there, Amazon is there, but only Qiskit is very famous because it is open source. So I can notice all this stuff. So why Qiskit is famous? Because it is open source. You are not only download this code, you are not only using this tool, and also you are able to contribute in the future. So this is good thing. Okay, if you are using any software, you should ask this question whether it is proprietary based or open source. Open source means you can download at any time. You can modify that software according to your need. So this is like tailor made. Okay. So please try to use open source software as much as possible. You are not only become the user, you are also become developer as soon as possible in future. Okay. So if you use this Qiskit tool, you can run 63 times faster when compared to other tools, which is developed by Google. So for your reference, I will share that link with you. So Google is developed under Google Quantum AI. So I'll share this link with you. So there are multiple developers are there. So go to this link and you can see what are all the development happen in Google. You can see their blogspot, white papers, video, specification sheet. Okay. Google also have some milestone according to their hardware development. Okay. They have error correction and you can find resources for study purpose. And they have courses in Coursera. Everything is there. But when compared to Qiskit, Qiskit have more documentation on proper channels. So when compared to Google. So you need to know all the options available in the market, right? And there are totally 7,000 projects, independent projects developed by using Qiskit software. So in future, if your students are developing, if you want to develop any project, try to use Qiskit as much as possible because it contains a variety of packages which is inbuilt. You can build application very easily. So no need to write from the scratch. You can build your application easily. So this is why I recommend Qiskit for everyone. Okay. So this is the whole summation of Qiskit. So quantum information science you can do with Qiskit, and you can do high performance computing. So you can use classical computer as well as you can use neuromorphic computer, and you can use server. Okay, GPU, TPU, everything you can use with the help of Qiskit. So QuizKit contains the whole framework. Okay, it contains heterogeneous orchestration. It means you can use high performance computing. Okay, you can use supercomputer, you can use digital computer, you can use laptop, even you can use IoT devices, everything integrated in the same environment. So this is one good thing. And what is the basic language you want to learn if you want to learn QuizKit? The Python is more than sufficient. So if you know Python, you can use this tool. You can write coding in this quantum platform. So learning Python is very, very easy for faculty from physics background, chemistry background, or mathematics background. So when compared to all languages, learning Python is somewhat more easy. So multiple vendors are supporting. So Qiskit is not only supported only from IBM, even Microsoft is supporting, Amazon is supporting. Okay, so all big quantum players are supporting IBM Quantum. So that is one good thing. So if you want to learn any tool, it should not be platform dependent. It should not be vendor dependent. It should be open. So everybody able to use the tool in their own hardware. Okay, so I highly recommend Qiskit because it will give much more freedom. Not only hooked to IBM Quantum, you can use this tool to write program for Google also, Microsoft also. So most of the time company won't agree, but in case of Quantum, everybody is contributing and there is a open communication happening between all these companies. That is very good, right? So take all these big company, they are supporting Qiskit hardware and Qiskit software. So what you can do with the Qiskit, okay, you can map a physical problem in the Qiskit and you can do optimization. So after optimization, you're able to execute that code. Then you can use the classical computer to post process. So step by step, they gave each and everything. So this is the second part about Qiskit, right? So if you scroll down, there are so many pre-built code templates. So it will save your time. Suppose if you want to develop your own, you can develop on GitHub repository. So I'll share this link. You can go and check the predefined template available for you. So these are the predefined Qiskit templates. I'll share this link with you in chat box. So if you have any doubt in between, you can ask me. I switched off my video, only I enabled voice. Whether my screen is visible? Okay, thank you. Thank you. So if you want to develop your own, what you can do, you can go to this Qiskit repository, so which is a branch out of GitHub community. Yes, we can possible. It is easy to incorporate IoT in Qiskit. So scopes are there. So wherever you can use sensor, you can include Qiskit. So all this IoT involved with analog sensors. Okay. If any signal is analog, and you can use Qiskit over there. So there is so much of correlation between analog and quantum rather than quantum and digital. So digital is human interpretation. Okay, analog is most basic in the nature. Okay, according to your domain, you can develop your own application. You can upload over here. If they will go through your code. If your code is good, they will incorporate. So we'll discuss introduction to Qiskit. So maybe in QT03 we'll cover if time permits. So until then, wait for some time. And where you can use quantum? Yes, I will tell about Raspberry Pi in 1 or 2 classes, upcoming classes. So this is very important. So before using any tool or any technology, you need to know where you can use it. So you can use quantum computing for optimization. So if your problem involves combinations, permutations, okay, so much of complex random calculation, then you can go for quantum. Okay. Then if you want to simulate any physical actions or chemical reactions, then you can go for simulation. So this is the main purpose we are involved with quantum. So you cannot simulate chemical reaction using classical computer or supercomputer. It won't help you. Okay. So to simulate complex system, any physical system or chemical system, you can use quantum computer. Okay. You can do simulation, not only simulation, you can run actual quantum computer. So the two ways you can use Qiskit. So I need to mention over here. So two ways you can use Qiskit. So one, you can use simulation. So this can be done in your laptop, CPU or server or supercomputer. Server or supercomputer. The second one is actual quantum computer. Okay. So most of the times what happen, you are able to simulate only up to 32 bit. So 32 qubit. So if you want to do any quantum simulation, you can do until 32 qubit. You cannot simulate. My screen is visible, I think so. I'm sharing the screen. If black color appears, please rejoin. Are you able to see my screen? I'm writing yes. Okay. Screen is good. Fine. So please try to rejoin. Please try to rejoin. So most of the time, if you are using simulation, okay, if you want to do simulation, this will support until 32 qubit, even if you are using supercomputer. Suppose if you are using 33 qubit, okay, the supercomputer will get collapse. Okay. So beyond 32 qubit, the only way to execute simulation or real-time execution only through quantum computer. So this is good thing about IBM Quantum. So if you want to create IBM account, you need to have credit card. Now they have strict conditions. So before 4 months, there is no restriction, but nowadays they are asking your credit card to verify your authentication. Okay. So next, what you can do quantum machine learning. So when I talk about quantum machine learning, people always try to ask immediate question: how to convert a classical machine learning problem into quantum machine learning problem? To do quantum machine learning problem or converting quantum machine learning, you need to wait for 6 months or 1 year, because you need to study the basics of quantum. Then slowly you need to understand how to convert a classical machine learning into quantum machine learning. So wait for some times. I will introduce course how to proceed until the quantum machine learning. The next important topic is partial differential equation. If you take physics, if you take chemistry, if you take mechanical engineering or aerodynamics, so most of the problem, interesting problem or complex problem, are in the form of partial differential equation. Okay. So if you want to solve partial differential equation, quantum computer will help you. So this is one good thing about quantum. So if your problem involves with all these four, you can go for quantum. And you can understand in what way you can contribute to Qiskit. So many ways you can able to contribute to Qiskit. First of all, you need to know about its ecosystem. So I will share this link. In your free time, please go and browse about this ecosystem. So you can add your project. If your paper is interesting, they will accept it. So you can find so many projects over here, and who is maintaining, you can get all these details. Okay. So according to the domain, they have most of the projects. So some project involved with the community, some project involved with directly with the IBM. You can go and check according to your problem. Very interesting. Okay. Then what you can do, you can apply for Unitary Foundation grant. So if you have some interesting idea in quantum, and if you are applying through this Unitary Foundation grant, if your project is interesting, they will call for interview. If you're able to crack that interview, they will give grant. So I have this also add some value if you want to do some projects in future to get funding. So this is international funding. So some of the students from India, they got funding from this Unitary Foundation. Okay. So if you want to add your project, if you want to do contribution, you can go to this link. They will give guideline. So if you go to this, go through this guideline, you know how to create a project, how to upload your project in Quizzkit. So this will be super helpful. So they will give entire guideline how to create a project and how to upload in this link. And they will give instruction how to install using Python, right? How to create a simple quantum program over here. So everything is given. So whatever the link I share over here, I will share after the session in the material. So don't worry about this link. Suppose if you want to know the latest development or any updated information, you can join in Quizzkit Slack. So Slack is a platform. I can show Slack software. So in future, if you want to develop any project, it will be helpful for you. So go and check this platform. So this is very easy. So within a single environment, you can contribute to multiple people and you can update the project status in a holistic way. So you can introduce to your student community also. So in future, if you want to monitor any project, it will be easy for you. So this software platform have file repository. If you are discussing with any title or any problem, so it will keep coming under like Gmail. So like thread. So it is easy for you to maintain your project as well as to develop your project. So this is one-stop tool where I can do everything in organized way. So this one I want to mention, if you want to understand Quizzkit, so there is very beautiful platform created by IBM. So go to this learning link. Go to this learning link. And this link contains multiple courses. Multiple courses. So all these courses are free of cost because it is open source. Okay. So all this material belongs to IBM. They put so much of effort. So in foundation, if you click the first course, it will come under the name Basics of Quantum Information. I'll share this link with you. So I recommend every one of you, please go through this course first. So if you want to start quantum from the very beginning, this course will be very helpful for you. Okay. So if you click the first lesson, single system, are you able to access this link? Am I audible? Are you able to access this link? Single system. Okay, good. So, look at over here. It contains title introduction, right? This course is taught by Professor John Waters, who is teaching quantum in Canada for past 30 years. Okay. So what you can do, you can watch this YouTube video or click over here. You can download slides. So multiple way you can study this course. So this is the PDF. Okay. This is the slide. You can take printout of this slide. You can take printout of this slide and you can study. You can study. Okay. So this is one way. Otherwise, you can watch this video, so which will go for 1.5 hours. So anyone watching video for first time, they cannot understand the entire video. You need to watch multiple times. So if you want to study quantum, you need to have some patience. You need to study very slowly, steadily. Okay. If you have any doubt, if you encounter any unfamiliar words, you need to stop that video and you need to do some basic Google research, then come back to video. So if you're studying through slides, you need to do in same way. Okay. So learning quantum is somewhat difficult, even though if you are coming from physics, chemistry, maths background, most of the time you will feel difficult because it is multidisciplinary, right? So during that time, you need to do some foundations, then come back to video. So once you completed all all this material, what you can do, you can take exam. So exam available in the last link. Once you completed all these course, please try to take exam. So this exam contains 20 questions. You need to clear at least 16. Okay. So this is free of cost, and you can take multiple times. So there is no restriction, right? So this is the first course, what I suggested. Once you completed basics of quantum information, then you can go for fundamentals of quantum algorithm. So this will be helpful if you are related to CS or IT, okay, IT background. Then you can go for advanced course, general formulation of quantum information. Okay, if you are interested in mathematical problem, yes, certification they will provide. They will provide certification. So don't worry about certification. So once you completed exam, the digital batch will come like this. Along with this digital batch, you will get certificate from IBM Quantum team. So to collect these batches, what you're supposed to do, you need to create Credly account. So I'll share this link. Very good question. So once you completed this course, no fees. I told this is free of cost. Free of cost. So go to this web page. Here you can collect your free Credly badge like digital wallet, digital purse. So this is my account. If you are using Gmail, you can create account in Credly. Suppose if you clear any Google certification, Microsoft certification, IBM, Oracle certification, AWS, all these certification batches you can collect in this Credly account. So this is my dashboard. And if I go to my profile, I can show you. So you can see the information about me, and any recruiter can check my profile from Credly. They able to know how many batches I completed. I completed nearly 15 batches. So most of them related to quantum. So you can arrange your Credly in this way. The more batches if you are collecting, the more chance the company will recruit you. So that is the foundational course. Okay. So what you can do once you created Credly account, you can share with your friend or HR. So easily they can go and check your profile. So very good question, Vinod sir. Suppose if you know data science, which will be useful in quantum computing. If you know quantum computing, which will be helpful to understand data science in better way. So whatever the knowledge you have, whatever the domain you belongs to, it will complement quantum computing. And whatever the effort if you are putting in quantum computing, it will complement your domain. So it is vice versa. So any department people, any domain people are invited to quantum to contribute. Very good, sir. So all these courses are free. Okay. Then what you can do, if you are from mathematics, you can focus on quantum error correction. So most of the opening in quantum, most of the hard opening will happen in quantum error correction. Okay. So if you want to use a utility scale, you can go for this last course. So this course will teach you how to use more than 100 qubits. So if you are advanced, okay, you can go for this course last time. BTech students, mostly the quantum computing industry won't take BTech students. So this is the real thing. So they will recruit MTech students. They will recruit PhD scholars after their completion. Okay, BTech only a stepping stone towards quantum. So immediate opening is almost impossible. So, but you can motivate your students. You can ask them to do masters, then slowly they will get some internship towards quantum. Then they can join in any reputed industry or reputed institute to do PhD in quantum. Then the companies will recruit. So normally BTech students are not eligible for quantum. irrespective of MCA, VCA, MSc, whatever the degree you have, it doesn't matter. Masters also stream is not important. People from physics, chemistry, maths, they're able to get selected in quantum. Even from people from commerce, people from BCom, okay, MCom, they able to join in quantum. People from finance, they able to join in quantum. So domain is not a restricted one. If they know how to create a quantum application related to their domain, then it will be easy. So take an example of people from MBA. If they are very much interested in stock market predicting, they can use quantum algorithm to predict the stock market. Okay. If people are interested in art, okay, they can use quantum computing to generate art. So stream is not a bigger barrier in quantum, in my perspective. So companies, you can see all these ecosystem I showed companies, right? You can see all these companies. So all these companies, scrolling right, Quantanium, Superstack, AQT, Alice and Bob, IonQ, Amazon Bracket. So all these companies are related in quantum, heavily related to quantum. Everything is useful. Sensing is very, very essential for quantum. If people know remote sensing, GIS, it will be helpful in quantum computing because in future, they will try to create quantum sensors. So whatever you are learning in remote sensing, they about to replace with quantum sensor, more accuracy. That's all. So in future, not just remote sensing, remote quantum sensing, it could be possible. Are you able to get the idea, sir? People from ECE EEE are most wanted in quantum. They can develop better circuits, they can do better optimization in circuit, and quantum will be helpful in VLSI design, better VLSI design. So department is, domain is not restricted. Okay, let me proceed. After sometimes you can ask your doubts. Okay, so we are discussing about the course. So once you completed foundation, you can look for focus topics. Okay, so advanced topics just like quantum machine learning. So if you click quantum machine learning, the course complexity will get increased multifold. Okay, they will start from classical machine learning. So if you already know classical machine learning, it will be helpful. So you can get a revision about classical machine learning. Okay, so once you do classical machine learning, you can do data encoding. PG diploma will not work as master degree in quantum because master degree in quantum is somewhat um, more intense. So it is not equal. It's not equal. But it will add value to better understand the problem domain or problem area. So doing master degree in quantum is very, very helpful to do a PhD in quantum or to get a direct job in MNC. So master degree is must in quantum. So I will discuss all these detail. So don't worry about all this stuff. First, we'll cover basics of this tool. Okay. So if you have data, your data need to be converted into quantum state. So they will give all this detail. Okay. So finally, you need to take exam. So somebody, if they want to study directly quantum machine learning, they can't understand anything. So this is my advice. So don't jump directly into quantum machine learning. Okay. So go step by step. It is like mathematics. Without knowing the previous fundamental step, you cannot step into advanced topic. So each and every one of you, please go through basics of quantum information. So advice to your students, always start from basic. Okay. Once you completed quantum machine learning, you can go for variational algorithm design, where you can use the classical algorithm with the quantum algorithm. You can create hybrid algorithm. So already you have some result, some existing classical result. You can combine with quantum. So this will be helpful if you completed all these previous courses. At least these two you need to complete: basics of quantum information, fundamentals of quantum algorithm. Then only are you able to proceed with quantum machine learning or variational algorithm design. Suppose if you are from physics, chemistry background, you can directly go for quantum chemistry after completing first two courses. So this is for people from chemistry background. Okay. So first two courses you try to complete, then go for quantum chemistry. Okay. So again, quantum chemistry, you need to complete this previous course, right? Suppose if you are from MBA department or commerce department or business domain, you can go for quantum business foundation. So this course is very, very easy. Anybody in the audience be able to understand this quantum business foundation. Suppose if you are interested in cryptography, okay, those people can go for quantum safe cryptography, quantum post quantum cryptography. So all these details are available in this course. So I recommend people from CS and IT who are very strong in cryptography to go for this quantum safe cryptography course. People from mathematics also, they can focus on cryptography, more and more mathematical operation. Suppose in future, if you want to teach quantum in your classroom, you can use these two classes. So if you click quantum mechanics, so this course contains so many videos, and you can have the demonstration of code, video, okay, quiz, everything is there. You can use this tool for your class. If you want to teach quantum, this will be the better option, right? So try to use this course in your class. So how, this is very important question for me. It depends upon the person. It definitely depends upon the person. Okay. So without knowing Python, you cannot understand this tool. So learning Python is very, very easy. Believe me. So if you are from different background, please try to take 2 days or 3 day classes from CSIT background people. They will teach you Python. So learning Python is very, very easy. Even school students, they can pick up within 2 or 3 days. So Python involved in this Qiskit is uh, very, very basic and very, very minimal. So don't worry. Start with the basic course. Everything will fall apart one by one. Okay. No need to learn Python. Just use this tool. So without programming language, today I try to teach with you. So don't worry. So click sign into platform. Click sign into platform. I'll share this link with you. If you don't have IBM account, if you are not able to create, don't worry. Just watch what I'm doing. So go to this link. So top right, click sign in. I already created account. Okay. Nowadays they are asking credit card for verification. So if you are if you don't have any problem to share credit card details, you can share. Otherwise, don't create account. So it is up to you, personal choice. So they will take some money, $1 or ₹2 or ₹10 they will charge. Then they will refund after verification. So this is my dashboard. This is my dashboard. So I'll come down. I'll come down. Okay. I need to use Composer. So click Composer. I'll share this link. Even without using account, I can use this link. So no need to create account to access this page. So go to IBM Quantum Composer, the last link what I shared with you. So this is called composer, like musical composer. Vinod sir will talk later. After the end of the session, we'll talk. So if you click this link, it will come like this. It will come like this. It contains 4 quantum bits, 4 classical bits. So here you can notice. So if you have pen and paper, you can take notes. So whatever starting with Q, it mentions qubits. Qubits. Qubit stands for quantum bits. Okay. So whatever start with C stands for classical bit. Classical bit. So it means it is like a musical composer. So you can drag and drop your quantum gates, classical gates over here. So to use this tool, the credit card is not required. You can directly work. Are you able to use without creating account? Anybody able to work? You cannot store, you cannot save, but at least you are able to access this tool. Please put in chat box. Yes, that is more than enough. That is more than enough. Okay. To access quantum computer, you need to have credit card detail. Okay. For sake of understanding, this is more than enough. More than enough. Okay. So what do you do? We need to create only one quantum bit, only one classical bit. What we need to do? We need to select this Q0, select this bin button. So delete qubit. So we need to create only one qubit. What I do? Click 0, click delete, click 0, select bin button. So I have only one qubit, Q0. So starting from 0, that is why it is one qubit. So same way, click C4. C4 stands for classical. So select minus, C3 minus, C2 minus. So I have one quantum bit, one classical bit. So do like this, all of you. And you can rechange your windows in such a way. You can drag and drop. So you click this line, you can rechange. Okay, you can rechange. So Q0 stands for quantum bit. Okay, this line stands for electrical wire, just like classical electrical wire. Imagine in such a way. This C1 stands for classical bit, which is mentioned by double line. Okay, so quantum is always by single line, classical is always by double line. So know this point. So quantum bit is always single line. Classical bit is always double line. So you can see multiple windows. Here you can see gate, quantum gate, classical gate, all gates are available over here. You can see probabilities, you can see state vector, you can see Q sphere. The right hand side, you can see coding part. Okay, everything is there. So this is graphical based, this is code based. Again, these three are visualization tools. So you can rechange your atmosphere or this ID by going to view panels. Okay, we can enable disable all these tools. What I do, I will disable code editor, go to view, I'll disable state vector, go to view, I will disable priorities. I enabled only graphical editor and QSphere. So QSphere stands for quantum sphere. Quantum sphere. So this is a visualization tool. This is a visualization tool. So there are two tools available. One is block sphere. One is block sphere. One is QSphere. QSphere. So generally in block sphere, you are able to visualize one qubit. Here you can visualize n qubit, multiple qubit. So this is the basic difference. So note down if you have pen and paper. So block sphere, if you are studying from physics, chemistry background, it is able to visualize one qubit. Okay, but QSphere developed by IBM, this tool is able to visualize n qubit or multiple qubits simultaneously. Okay, so they gave two views. This is graph view, this is table view. So both will be helpful if you want to understand. So click graph view, click graph view. Okay, so initially all qubits are initialized to stage 0. So by default, all qubits are initialized to stage 0. So note down this point. Okay, so by default in IBM, especially in IBM Qiskit, all qubits are initialized to stage 0. So stage 0 is mapped to North Pole. So if you see over here, this is North Pole. Okay, downside is South Pole. So all of you know block sphere? All of you know block sphere? Shall I need to take one more time? All of you know block sphere, or I need to take one class about that? Shall I take one more time block sphere? Yes or no? Okay. Somebody told yes, somebody told no. Okay, better. Better I'll take block sphere because it is very easy way to understand quantum if you start from basics. So teaching quantum is always challenging because block sphere is very essential if you want to understand. No issue. We'll take block sphere as well as Qiskit. We have two more classes. So I'll take one more time. Okay, block sphere. So block sphere is a sphere which is made up of radius equal to 1. Okay, unit radius. Okay, so this is a visualization tool to view about your quantum bit. Okay, so this block sphere is divided into two hemispheres, exactly into two halves, because we need to represent two level system. So always we are representing binary data binary data. So if you want to represent binary data, you need to use binary system. Binary system. So what is the meaning of binary system? It is two-level system. So it could be on, off. It could be yes, no. It could be true, false. It could be 0 voltage to positive 5 voltage. Okay. So it could be black, white. So two information, okay, which are totally opposite, which are totally orthogonal to each other. So this is the idea about binary system. Okay, yes or no, true or false, on and off. Okay, fully charged, fully discharged. So two distinct system. Imagine such a way. Okay, and what we are doing, we are creating three axes. So these three axes are called Cartesian coordinates. So what we are doing? We are doing Cartesian coordinates to represent any points. So what are the Cartesian coordinates? Generally x, y, z. So if you have 3 points, you can represent any point in this block sphere or sphere. Okay. So for this, you need to have 3 axes. X, Y, Z axis. So 3 coordinates. Okay. And what we are doing, we are taking 2 extreme points. So these 2 are called extreme points. So here we are mapping our quantum states. What are our quantum states? We have 2 states, state 0 and state 1. So we are mapping these 2 states in block sphere. So this is equivalent to classical bits. This is equivalent to classical bits, and which are called polar states or pure states. So know this point. So we are converting our binary data into quantum data. Okay. How we are mapping? We are mapping physically. So 0 means North Pole. Okay. 1 means South Pole. Right. So after mapping, what we are doing, we are taking a random point in your sphere, a random point in your sphere. So imagine this green dot. I'll take highlighter. Imagine this green dot is your quantum bit. It could be your electron, it could be your ion, it could be any subatomic particle. It could be anywhere in your sphere. Okay. So to understand this point, to know the information, okay, what we are doing, we are generating a vector. So this vector originating from origin towards the quantum particle location. So what it will give, this state vector will give information about will give information about quantum particle. Okay, what could be your quantum particle? It could be ion, it could be electron, it could be any subatomic particle. Any subatomic particle. So note down this point. So this is called quantum state vector. Because it is pointing to quantum particle, now it denotes quantum state vector. Fine? Okay. So how will you describe this point technically? So this point is called mixed state in between state 0 and state 1. In other words, you can say it is a superposition. Superposition. Superposition state. Okay. These 2 points are pure states. So these 2 points are pure states. So all other point over this sphere, inside this sphere, are called superposition state or mixed state. So this is the analogy. And what we are doing, we are slicing the sphere over this point, over this quantum particle. Okay. So this will get x dash and y dash plane. From this plane, what we are doing? We are doing a projection. We are doing a projection towards xy plane. XY plane. Okay. So what about this plane? This xy plane is called equator. This xy plane is called equator because exactly it will divide your sphere into two halves. Exactly divides your sphere into two halves. So I'll clear this slide. Now we can visualize. We took a random point. From that random point, we are intersecting that sphere. It will create x dash, y dash plane. From that plane, we are creating a projection towards xy plane. Okay. Then we are doing one more projection towards origin. So this is projection 2. Projection 2, we are doing towards origin. So this is the intersection point. This is intersection point in xy plane. So once again, I will repeat what we are doing. We are taking a random point and we are creating a vector from origin. This is called quantum state vector, mixed state. From this point, we are creating a auxiliary plane, x dash, y dash plane. From that intersection, we are doing a projection to xy plane. From that intersection, we are doing one more projection towards origin. So if you are doing so, what you are doing, you are creating a right angle triangle. A right angle triangle you are doing. Okay. So once you got right angle triangle, you can apply trigonometry. So this is the basic. To apply trigonometry, we are creating a right angle triangle by doing two projections. Okay. So this will create an angle between your z-axis, your quantum state vector. So theta is angle between z-axis to quantum state vector. So this is the first angle. Okay. In same way, we can generate second angle psi. Psi is angle between your x-axis to downside projection. Downside projection in xy plane. So this is for your understanding. I'm writing so you can remember. Okay, from a random point, from a mixed state, from any superposition state, we are able to do two projections. If you're able to do two projections, you're able to create two angles. From two angles, what you can do, you can represent Cartesian coordinate into polar form. So all these steps we are doing because we need to convert Cartesian form into polar form. So polar form involved with angles. Not on the surface, inside sphere. So technically inside sphere, not on the surface. So imagine if your angle is 0. Imagine if your angle is 0. Okay. So this equation is called wave equation. This equation is called wave equation. So if you want to define any quantum particle, if you want to define or describe any quantum particle, you need to know this equation. Okay. So this is nothing but quantum state. Quantum state, or you can say this is about quantum particle. Radius is not different because unit radius. So that is why I define the radius equal to 1. Always the radius equal to 1. Okay, please recall. Once again, I will repeat. Just try to follow. So what this equation is about? This is called wave equation. Okay. So wave equation describes psi. So uh, this symbol is called psi. Okay. Psi contains two components, state 0 and state 1. Okay. We are involved cos component and we involve sine component. So cos and sine are opposite to each other. So recall the trigonometry. Okay, sine and cos, we try to represent opposite dimensions or opposite signals. Okay, if you don't know one part of the triangle, one length of one side of a triangle, you can apply sine. Or if you don't know the other side, you can apply cos. Okay, so sine and cos are complementary or opposite to each other. Okay, same way we can apply this sine and cos to state 0 and state 1 because these two are opposite in nature. Okay, sine in 0 in north pole, 1 in south pole. So if two components are opposite to each other, then you can represent with the help of sine and cos. Okay, it involves with one more angle, e to the power I psi. Okay, this is theta, this is first angle, this is first angle, this is second angle. So two angles we generated, right? Two angles. So recall the previous slide. What is the meaning of theta? This is angle between your z-axis to quantum state vector. Suppose if theta equal to 0, if theta equal to 0 degree, what happens? If theta equal to 0 degree, what happens? It will point to north pole. Are you able to realize? It will able to point north pole exactly in z-axis. So there is no angle difference between z-axis to your quantum state vector. Very good. Very good. Okay. So apply theta equal to 0. Yes, exactly on z-axis. For understanding, I'm saying to north pole just for easier understanding. Apply theta equal to 0 and tell me what the value will get. What is the value you will get if you apply theta equals 0, cos 0 by 2, sin 0 by 2, what you will get? Put in the chat box. So cos 0 by 2 is 1. So this will give 1. 1 into state 0 plus sin 0 by 2 component is 0. 0 multiplied with state 1. Whatever you do over here, everything is multiplied with 0. So you'll get only state 0. You'll get state 0. Very good. Very good. So this gate, so this action denotes identity gate. Identity gate. So what it means, if you apply d equal to 0, the state remains as it is. Quantum state remains as it is. So it is like a pause button. It is like a pause button. Okay, it will do nothing. So identity gate will do nothing. It will not do any state change. So it will retain as it is. So you can understand in this way. So wherever the quantum state is there, if you apply d equal to 0, it will do nothing. It will do nothing. I'll explain. Wait, one by one, I try to explain. Suppose if we apply d equal to pi. Now do calculation. So apply d equal to pi, cos pi by 2, sin pi by 2. What is the value you will get? Exactly get 1. Get 1. Very good. Very good. So what do you do? So this component becomes 0. This component become 1. So 1 into state 1, you will get only state 1. So what it means, if you apply d equal to pi, so it will do a pi rotation over your x-axis. So imagine your quantum state vector is pointing to north pole. If you apply d equal to pi, it will do state flip. So classically, it will do bit flip. So 0 to 1, 1 to 0, which is nothing but not operation. So this is equivalent to not gate. So people from ECE EEE, you can understand not operation. So d equal to 0, what will happen? It will go for identity gate operation. D equal to pi, what it will do? It will do not operation. From stage 0, if we apply d equal to pi, it will go for state 1. From state 1, again if we apply d equal to pi, it will go back to stage 0. So from here, if we apply d equal to 0, d equal to pi, it will go back to stage 0, not operation. So like bit flip, it is a state flip. Okay. So next, what we do, we apply d equal to pi by 2. So apply d equal to pi by 2 until where it will go? Till where it will go? So please put in the chat box. If you apply d equal to pi by 2, 45-degree angle, very good. Superposition, very good. So any more answer? Between y and z, mixed state, 45-degree, x-axis, xy plane, definitely xy plane, not in x-axis, it will over, so not in y-axis, it will go for x-axis. Because it is operating from y-axis. So if you imagine like this, okay, this will be rotated over x-axis exactly half the distance. Exactly half the distance. So it will go to x-axis, not y-axis. So what it will do half not operation. What is the half not operation? So not operation means from 0 to 1. Okay, 1 to 0. This is full not operation. Full not operation. Okay, what is half not operation? It will do rotation from xy axis over x-axis. This is called positive state. Okay, exactly 50% away from stage 0. Exactly 50% away from state 1. So that is why it is called equal superposition. Equal superposition. So where equal superposition avails? Equal superposition only available in equator. So note down this point. So equal superposition in block sphere only available in equator. Where equator exists? In xy plane. Okay, if you apply theta equal to pi by 2, it will create equal superposition, not just superposition. Superposition means it could be anywhere. It could be anywhere in your sphere. Okay, so look at the second angle. Here, psi we are applying theta equal to pi by 2. So this is called phase shift. Okay, from x-axis, from positive state, if you apply the second angle psi equal to pi by 2, it will move along xy plane towards x-axis. You can see over here. Sorry, towards z-axis. Towards z-axis. Imagine this z-axis rotating in clockwise. Sorry, anti-clockwise. So this y-axis is called positive I, or simply I, ket I. So try to recall. Okay, if d equal to 0, identity gate, do nothing. If d equal to pi, it will do not operation. If d equal to pi by 2, it will create equal superposition. Okay. If the second angle psi equal to pi by 2, it will create equal superposition, but in different location. So normally x-axis is called real axis. Real axis, it contains real components. So note down this. So x-axis normally called real axis. Y-axis normally called imaginary axis. So it contains imaginary components. So whatever the point we have in Q sphere, we have in block sphere, it is a complex number. So that is why all quantum state vector contains two components. One is real, one is complex or imaginary. So this is very important in quantum. Now we try to recall what we covered so far. So we have z-axis. So z-axis is called computational basis. Computational basis. So whenever you do measurement, your quantum state will go to z-axis. So what z-axis contains? State 0, state 1. What z-axis contains? State 0, state 1. Okay. What x-axis contains? Positive state, negative state. What y-axis contains? Positive y, negative y. So we have three pairs. Okay, state 0, state 1 in z-axis, positive state, negative state in x-axis, positive y, negative y in y-axis. So if you have three pairs, you can represent any quantum state in your block sphere. So this is the idea. This is the idea. I'll show in demo. Just wait for a few minutes. Okay. So stage 0, you can represent with 1, 0 as a matrix. So this matrix is in the form of column. This is a column matrix. Okay. So we have 1, 0 representation. Why 1, 0? So the north pole is upper component. The north pole is, or northern hemisphere is upper component. So this is the upper component. So this is upper component. So this is southern hemisphere. Southern hemisphere, lower component. Okay. So look, where stage 0 exists in north pole. So it is related to northern hemisphere. That is why the upper component is 1 over here. So what is the relationship between stage 0 in southern hemisphere? No relationship. That is why the lower component is 0 over here. So in quantum, you are able to visualize the mathematical representation. So mathematical representation have some physical meaning over here. Okay. So stage 0, where it existed in North Pole. That is why the upper component is 1 over here. The lower component is 0. So if you want to represent 1, which will be opposite for this, which will be opposite. Okay. The lower component become 1 because state 1 is represented in South Pole, Southern Hemisphere. Okay. I hope everybody able to follow. Okay. So look at the positive state. Positive state, where it exists exactly between North Pole and South Pole. So 50% away from state 0, 50% away from state 1, exactly in the equator. That is why both components are there. That is why both components are there. So imagine the component over here is 1, 1. But for positive, it is 1 over root 2. But for positive, it is 1 over root 2. I'll explain in future class. So just recall. So positive state belongs to both state 0, state 1, exactly in the equator, related to northern hemisphere, also southern hemisphere. That is why both components are there. Okay. So look at the negative state, which is in opposite side of positive, opposite side in this sphere. So that is why you can represent negative sign for the second component to represent opposite side. So negative sign have some physical meaning over here. Okay, to represent opposite side. So in same way, if you want to represent y axis I state, okay, y state, or you can say, so 1 over root 2, 1, the second component is become imaginary. Same way for minus I state, the second component become negative, negative y. So all of you able to follow until this? So what you can do, we can visualize block sphere in mathematical matrix form. So state 0, 1, 0, state 1, 0, 1. Okay. Positive state 1, 1, 1 over root 2 multiplied with negative state 1 minus 1 multiplied with 1 over root 2. So across the equator, 1 over root 2 is common factor. 1 over root 2 is common factor. So I will explain this reason in future class. So just note down. To understand block sphere, you need to work a lot. To understand block sphere, you need to work a lot. So what I do, I try to give this slide link. So this is very good tool if you want to understand block sphere operation. I'll share in the chat box. Because block sphere is very important if you want to understand physics. So investing in block sphere is very worth for you. So go to your browser. Go to your browser. So click over here. Are you able to launch this tool? Are you able to launch? Very good. So whatever I explained in this previous slide, these two are called pure states. Pure states. These two are called pure states. Okay. So initially, by default, it is pointed to stage 0. By default. So note down this point. Initially, if you click this website, it is pointed to stage 0 by default. Okay, these two are called pure states. So if you want to prepare qubit, if you want to prepare a new qubit, a new qubit, quantum bit, okay, you have only two choice, either stage 0, either stage 0 or state 1, because these two are known states. These two are known states. Why these two are known states? Because we are representing binary value. Binary value. So how many states in binary value? Either 0 or 1. So that is why if you want to create any qubit, okay, you need to prepare either in state 0 or state 1. Okay, so normally qubit exists in superposition. So you need to calibrate the qubit either to state 0 or state 1. So people from physics and chemistry, they will ask so many questions. Okay, qubit is always in superposition. Even though if it is in superposition, for quantum experiment, you need to calibrate either to state 0 or state 1, either in upspin or downspin. Because from the known position, you are able to calculate anything. If it is unknown state, you cannot use the qubit for computation purpose. Okay, so before doing anything, we are starting from 0 or we are starting from 1. So imagine such a, okay. So click state 0, it is pointing to North Pole. Click state 1, it is pointing to South Pole. So do this. So this is block sphere. Block sphere is only for 1 qubit. So click state 0, click state 1. Okay, 0 means you are preparing qubit in North Pole. 1 means you are preparing qubit in South Pole. Okay, the first gate we are exploring is called X gate, which is NOT gate. Which is NOT gate. What it will do? It will do bit flip. It will do bit flip. Okay. So take an example. We are in stage 0. Click X. It will move to state 1. So what we got? We are in stage 0. We applied X gate over here. It will turn into state 1. So what is happening? It will do bit flip. Okay. Suppose if you are qubit in state 1, again if you are implementing NOT gate, X gate, it will turn into state 0. Again it will do bit flip. So you can imagine in this way, applying X gate in state 0, it will move to state 1. Applying X gate in state 1, it will move back to state 0. So applying 2X gate will cancel each other. Yes, you can ask a doubt. Okay, no issue. So click X from state 1, it will go back to state 0. Apply X, it will move back to state 1. Again apply X, it will move back to state 0. So it is a bit flip, not gate. It is not a quantum gate, it is a classical gate. Okay. Whatever the classical gate you are able to create, you are able to create in quantum also. So quantum will support classical gate operation, but reverse is not possible. Okay. All classical gates are implemented in quantum, but all quantum gates are not implemented in classical. Okay. So next gate is very interesting. So this is called Y gate. So what Y gate will do? It will do bit flip along with phase flip pi by 2. So note down this one. So whatever X gate will do, Y gate will do the same thing. Additionally, it will do pi by 2 phase flip. So just check. Now it is in stage 0. So click Y gate, it will move to state 1 exactly like X, but downside we can see difference in phase 0 to pi by 2. Okay, from state 1 again do Y gate, it will do bit flip to state 0 along with pi by 2. Okay, it will cancel each other, again it will go for same state. So applying 2Y gate next to next will cancel each other. So it means X gate have its own inverse. Okay, so X gate have its own inverse. Y gate have its own inverse. So like hero and villain, it is like a mirror image. It is like a mirror image. Okay, click 0, click 0, click Z gate and see what happens. So click 0, apply Z gate and tell me what happens. Put in chat box. Put in chat box. X, nothing will do. So nothing will happen. Okay. So Z gate will act identity gate. So from stage 0, if you apply Z, it will lead to identity gate, identity state. No change. So no change. Great analysis. Okay. So click state 1, apply Z and observe what happens. So click 1, apply Z and tell me what happens. So it will do phase flip about pi rotations. So it will do phase flip about pi rotations. So this is positive side, this is negative side of your sphere. Imagine this side is positive, this side is negative. So it will do phase flip pi rotations. Okay. So apply Z gate from state 1. What it will do, it will introduce pi rotation, which is indicated by negative sign. Okay. Suppose if your state in minus state 1, if you apply Z gate, it will go for positive state 1. So check this. So note down this equation. From state 1, if you apply Z, it will go to negative state 1. From negative state 1, if you apply Z, it will go to positive state 1. Are you able to observe over here? So physically, you cannot see any change, but below this block sphere, phase change you can see. Minus 1 is this side. You cannot see physically, but see the phase change, that is minus 1. That is what I told. Okay, very good. Very good. So click stage 0. You can see in phase, but in signal it is very difficult. So click stage 0. Click stage 0. Okay. Click H gate. Click H gate. So H gate stands for Hadamard gate. Hadamard gate, what it will do, it will create equal superposition. Equal superposition. Exactly in the equator. Okay. From 0, if you apply Hadamard gate, sorry about that. If you apply Hadamard gate, it will go to positive state. Okay. From positive, if you apply Hadamard, it will go back to stage 0. It will cancel each other. So click 0, click Hadamat, it will create positive state. Okay. From positive state, again click Hadamat, it will go back to stage 0. So applying to Hadamat, next to next will cancel each other. So it means all these gate X, Y, Z, H has its own inverse. So if you apply the same gate next to it, it will cancel each other effect. It will go back to original state where it is started. So that is the logic. That is logic. So click 0. All of you click 0. Click Hadamat. Click Hadamat. Click Z gate and tell me what happens. So I will write this equation. So all of you click 0. Click Hadamat. It will go to positive state. From positive, click Z and tell me where it goes. Put in chat box. Exactly, it will reach to negative state. Negative state. So why negative state? It will do pi phase rotation from positive side to negative side. Now you able to understand. Now you able to understand. So from state 1, you cannot see physically, but any superposition state you able to see physically about this Z action. Okay. So click Z from positive, it will go to negative. From negative, apply Z gate, it will come to positive. Now you able to understand the Z gate. From positive, if you apply Z gate, it will go to negative state. From negative, if you apply Z gate, it will go back to positive state. Okay. So I hope you are well introduced to qubit block sphere. Okay. Now what we do? Now what we do? We try to implement NOT gate. So drag and drop this crosswire. So this is NOT gate. Now what you are able to see? So all qubits starting from 0. Okay. We implemented NOT gate. What NOT gate will do? It will do bit flip. So state flip you can say in quantum. Okay. So it will generate a power supply over here. So power supply over here. Imagine this is off. So state 1 means it is on. So you need to show difference, right? So 0 means off, 1 means on. What happens if on? Power supply will get generated. So that is why state 0 now move to state 1. So from North Pole, now it is pointing to South. So here you can see the color change, which is in blue color. Are you able to see the difference? So click this NOT gate, press delete button. Again, it will remove NOT gate. You will get only stage 0. So move your mouse over here. You can see Q0, phase is 0, real part is 0, imaginary part is 0. Probability of state 1 is 0% because it is showing stage 0. Okay. So drag and drop NOT gate. Again, you can see changes over here. So move your mouse over here. Probability of 1 is 100%. Now everything is changed. So click table view. You can see the details. So 0 means 0% probability. 1 means 100% because we implemented NOT gate. So select this NOT gate, press delete button. Again, you can see changes. So what is the probability of stage 0? 100%. What is the probability of state 1? Now 0%. So click graph view. So you can change graph view and table view by varying your visualization. So you can select phase angle. You can see color changes also. So note down over here. You can see state and phase angle. So enable this phase angle. So what we do? We drag and drop two NOT gate. So today we discussed without coding. Don't worry about the coding part. We will cover tomorrow. So stage 0, we implemented first NOT gate. Okay. What first NOT gate will do? What first NOT gate will do? It will flip into state 1. Again, we are applying the second NOT gate. What second NOT gate will do? It will do bit flip from state 1 to state 0. Again, you'll get state 0. So two NOT gate will cancel each other, which will lead to original state. So this is what I described in block sphere. So apply two NOT gate next to next will cancel each other. So if you have this situation, try to avoid. Try to avoid. Because no use of it. Okay. So select this NOT gate, delete. Select this NOT gate, delete. Now the second gate, drag and drop I gate, which is identity gate. Drag and drop this gate, I gate, identity gate. You can see nothing over here, no changes. What do you do? Drag and drop NOT gate. So before I gate, you will get state 1, or after I gate, you will get state 1. So identity gate will do nothing. It will pass the state as it is, like a pause button. So you can apply n number of identity gate, which will do nothing, no changes. Okay. So when you supposed to apply I gate, when you want to pass your quantum state for some times, when you want to pass your quantum states, otherwise it will do nothing. So in some cases, you need to use identity gate. You need to identify that situation. Okay. So what are the gates we covered? NOT gate, then Y gate. So resize this gate, and drag and drop Y gate over here. Drag and drop Y gate over here, and you can see bit flip. So stage 0, we applied Y gate. What Y gate will do? It will do NOT operation plus pi by 2 phase flip. This phase flip denoted by color change. So downside you can see color change. Maybe I'll zoom. Are you able to see the color change over here? Phase angle pi by 2. Are you able to see my zoom version? Is it visible? Okay, good. So next what you do? Drag and drop Y gate. One more time. Drag and drop Y gate. Which will cancel each other. It will pointing to stage 0 back. So delete this Y gate. Okay. What do you do? Drag and drop H gate, which is called Hadamard gate. So if we apply Hadamard gate in block sphere, what we saw, it will go to x-axis. Okay, equal superposition. At the same time, it is pointing to north pole as well as south pole. Okay, so in this Q sphere, it is little different. Okay, you can see over here, it is pointing to both north pole and south pole. It is called superposition. So move your mouse over here. The probability of stage 0 is 0.50. State 1 is 0.49. 50-50. Almost a fractional difference is there. Almost 50-50. So this is called superposition. So what Hadamard gate will do, it will generate output sometimes 0, sometimes 1. Okay, what is the probability of generating 0? 50%. Generating 1, 50%. Black sphere, it is little different. Little different. It is equal superposition. At the same time, it belongs to North Pole as well as South Pole. So in Q sphere, little different visualization, that's all. At the same time, it is pointing to North Pole. Same time, it is pointing to South Pole. The logic is same, but the way you are seeing is little different, that's all. Are you able to get the idea? So it is like a cat is standing over the wall, exactly middle of the wall. So move your mouse over here, you can see the change in probability, 50% for 0, 50% for 1. Okay, so what do you do? Apply one more Hadamard gate, it will cancel each other. So whatever I described in block sphere, you're able to visualize in this Q sphere. So if we apply 2 Hadamard gate, it will cancel each other. Okay, so what is the example we saw? We applied Hadamard gate, then we applied Z gate, it will go to state I. It will go to state I. So this is what we covered, right? I state. So this I state is represented with this red color, phase angle pi. Are you able to see? Phase angle pi. So look at the table view. You can see phase angle equal to pi, negative side. So I can visualize over here, stage 0, apply Hadamard, it will come to positive. From positive, if you apply Z, it will go to negative. So this angle is given over here with the color change, red color. So to understand this, you need to understand this phase angle. Maybe today you go and check this phase angle. So look at this phase. So wherever pi is there, red color. Okay. Wherever pi by 2 is purple and blue. Wherever 0 is involved, this blue color. Okay. Wherever 3 pi by 2 is there, this orange color. Orange and yellow mixed color. So within this, I try to stop over here. I try to answer your question one by one. So automatically the state will change. I hope most of your question I already answered during session. So still, if you have any question related to block sphere or quantum gates, you can put over here. So before that, I will tell if you want to know gate information, where you can get, So click any gate, right click view information. You will get a basic detail about your quantum gates or any gates. Okay. So if you don't know what is the meaning of superposition, right click it and they will describe the superposition. So it is like a dictionary. Okay, very easy for you. If you are taking class using this quiz kit, very helpful. Okay, so if you want to know the quiz kit reference, you can click this. It will show a small code. So how to use that gate, what is the logic, everything is given. So today, so please go and use this block sphere. Polar equation we can get from Qiskit, but that is not scope of this topic. So anyway, I will tell you. This is more than enough. You can use penny lane. In upcoming class, I will tell you if you want to know about quantum machine learning. So anything related to Qiskit, anything related to Blocksphere, please put in the chat box. Blocksphere, you cannot represent more than one qubit. Multiple qubit gate you can demonstrate, but not more than one qubit. Q-sphere you can visualize. So tomorrow I will show how to represent two qubits in same Q-sphere. I will explain all these gates. So whatever the gates available over here, I will explain in tomorrow's class. Tomorrow we will try to cover the coding part also. So this is for basic beginners. So there are so many alternatives for Qiskit, so many alternatives, but I recommend Qiskit for each and everyone, easy for you. Yes, a spherical polar coordinate system, exactly. Not block sphere, blotch. The spelling is BLOCH, blotch sphere. Thank you all. I will share this slide to the coordinator or in the repository I will upload. So if you want to connect with me, just connect with me. I will share my social media ID. I am active in LinkedIn. You can follow me. So this is my ID. I will post frequently. Thank you all. Using unitary matrix of individual gate, we can compute state. Yeah, we can do. Mathematically, we can predict each and everything, but if you go for actual quantum computing, the state will change randomly. Little bit of randomness added between each and every gate operation. Even though for not operation, not all the time you will get bit flip. Sometimes you will get the same state. So that is more interesting about quantum. Okay. So if you apply NOT gate for 50 times, nearly 4 or 5 times you will get same state. It will not do bit flip also. So randomness is totally make you mad in quantum.
Uh, yeah, participants, any more queries? Chat में कुछ answered. No? Right. Thank you, Dr. Jaykumar Vaidyanathan, and of course the the participants will continue to appreciate. Thank you very much for taking this session at a very short notice. And we'll continue with two more sessions on simulations, which are not there in the syllabus actually, which are coming in QT03. But we wanted to give it last time also when we did the QT02. We did the same thing in MNIT series also. So in APSCHE series also, we thought we will have the simulation so that you will just pick up some basics. The content is placed here basically so that you will have about 2 weeks time before the actual programming is taught. You are given the basics, you are given the websites where you have to visit, you have to create your accounts. I am sure while sir was explaining, as slowly he was explaining, you have all created your own accounts and you have accessed some of the things. You can run some of the sample codes that are given. So we can do that. Yeah. This will be coming. The things that you're expecting in one more session is there on Qiskit. As you see, it will come shortly, and then there some more Qiskit explanation with QASM and Q inverse will be explained October 10th. October 11th, we will do a little bit of a brief idea on penny lane and using quantum machine learning. We'll try to get introduced to that. So hopefully we'll get all our doubts clarified and we'll get the confidence. And quantum programming will involve a lot of detailed explanation on this and also how to use the cloud, how to get that, how to access the 10 minutes time and all that things will be explained. So as of now, this is a special consideration for you that is given that Qiskit, Q inverse, QASM, and penny lane are introduced. QSM also will be introduced. So you will be able to take it forward. So we'll meet tomorrow. Tomorrow we'll continue with the actual syllabus as such. So there will be quantum key distribution will be explained by Dr. Anindita Banerjee. Dr. Anindita Banerjee is from CDAC and she has been, she already taught in QT 001, one session she has taken. So hopefully we will listen to her as she will explain quantum key distribution, which is another important aspect. Of course, we are just missing out a little bit of quantum cryptography. If you have done, I would have been more helpful. But anyway, quantum key distribution is slightly different in that sense. It comes to quantum communication. We'll try to look at that. And then we'll come back to quantum cryptography and post-quantum cryptography during October 13th and sometime like that and complete the syllabus. So we will look at quantum key distribution and then again Jay Kumar sir will continue his sessions. Somewhere at that time, we will have that quantum cryptography session coming in. So with this, quiz 2 will start on 10th of October as scheduled on Friday evening based on the syllabus that has been covered. So yesterday's material and today's material, we'll try to post it and keep you posted. So please follow the videos till that time. So 10th onwards will start and will be available till Monday evening. And the last session will start on 16th and will be over if you want the certificates before Diwali. So please complete the exams on time. So 16th onwards, 16th, 17th, 18th, if you complete, we'll be able to give the certificates by Diwali. Otherwise, we'll give the certificates after Diwali. You can use the Diwali holidays also to write the exams. Choice is yours. No hurry because we'll start the next course immediately. The quantum programming will start. We will announce the quantum programming this week, the curriculum and schedule and the speakers. We'll fix it and we'll announce. And the registration will also be open for QT03. Please be ready with the course, right? So thank you so much. We'll stop here and we will meet again on that is tomorrow at 3 o'clock. I think that should be fine. Thank you. Thank you so much, Jaykumar sir. Thank you, Anil sir. Anil sir, anything you would like to add?
Thank you, sir. Sir, I think is it fine to announce that who are seriously involved in this program can be selected for algorithm like thing?
Right,
yes. Right.
Sure, sir, definitely. Yeah, actually, some of you who are keen, we are trying to look at another training program which will be held parallel in some time. So please, we'll look at the performance of QT00 and 01 and also based on your qualification because it will be mostly with reference to computer science and people who are good at algorithms because it will be a slightly advanced course. So we are looking at that, and it will be a course along with students. Some of them will be selected from the hackathons that are being conducted. So IBM will be willing to train some of them. Of course, the PG certificate training program is anyway open for all of you at various centers. We'll try to do that. That will be PG certificate from AICT, but this is the second level program which is coming up, and it will be definitely shortlisted. They want to do multiple programs like that. Please don't worry. But some of them will be selected for the first level. Some of them, some of your friends, and some of you also have covered the advanced courses till QT07 in the MNIT series. So some of them who are from Andhra Pradesh will be selected for Train the Trainer program. And of course, once you also finish the 7 courses, some of you from QT 00, 01 and so on, it will go on till 00 and 01 has been together. So 03 and 04 will be together. So till that time, it will be 3 courses, then 5, 6, 7, 8. So there will be totally 7 courses comprising of 9 topics, right? So nine courses covered as 7 subjects or 7 courses. So the 7 courses, those who complete will again be selected for a training program. Maybe after your interim exams over, summer, we'll have another round. But IBM and National Quantum Mission was and AP State Council for Higher Education, Professor Madhumurthy sir, wants to do at the earliest, so that some of you are ready to handle some of the trainings which are needed by the time the system is ready in Amravati Quantum Valley. So I wish you all the best. So let's hope we'll see how to cover QT 00 and 01. We will try to provide the MOOC course shortly. Please wait for the instructions. It is not ready. Even the MNIT series, the QT01 course is not ready. So we are working. Actually, a lot of things are going on parallelly, you know. So once we are able to do that, we'll definitely, please be patient. We'll announce QT00 and 01 together. And you continue. There is no restriction, but of course, the videos are available. If you want QT00 and 01, the videos are available. You can go through, but we are concising the videos, beautifying the videos and making it topic wise. And then you can do it as a MOOC course. You can attend all those videos and take the quizzes related to that and get the same certificate, which MNIT will be giving. So please don't worry about that, but be little patient, give us some time. We'll fulfill all the requirements, right? Thank you so much. We'll meet tomorrow at 3 p.m. How to access those videos? Just go to YouTube, type QT00 and 01 and MNIT and EICT. These are the keywords, right? If you type that, you will be able to get that. एक बार करके दिखा दो. वही इसी चैनल पे. हाँ एक्चुअली यहाँ दिखा दो, शेयर करके आप करो, कैमरा बंद करो. You can watch here, see, share करो, screen share. YouTube में चले, फ्रेश में चले, वहां से चलो, प्लेलिस्ट में नहीं, YouTube में जाओ, उनको दिखाओ क्या करना. Are you able to see the screen? You're just typing QT00 and QT01. It's quite popular now. And you can just see that it will display that Foundations of Quantum Computing and Applications. So this is the series. These are the 20 days and 40 lectures that are there, right? So please look at all of these and then you can try to look at it, right? Okay, thank you. QT00 and QT01 are 2 different courses, but we have combined them. Camera on. we are combined them because the content was basic. So we try to cover them a little fast. QT03 and 04, 04 has hardware content. We will cover that a little later, but some part of it is software in QT04. We have merged it with QT03, so we'll give it QT03, 04 together, and that's how we are getting QT00 and 01 together. So that's how we are trying to run those courses, because hardware labs we don't have as of now. So some of the components are there that may be there in your physics department labs. So you can try to do those experiments by discussing with your physics faculty. They'll be able to help you, but otherwise that is how we try to do it, right? Thank you so much.